Hi everyone, Dankman. So we're going to continue with 5.1, multiplying polynomials. Okay. And I'm just going to do two example problems. Because sometimes when you multiply polynomials in a special way, neat things happen. And sometimes there are kinds of notation, that means the symbols we write down on paper, that can be a little bit confusing. So let's start with sometimes when you multiply polynomials together, sort of neat things happen. Okay, this is the example x plus 4, the group, times x minus 4, the group. Okay? Now if you recall, it's possible to represent this with a picture. Okay? Pink, 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 right? So we would have x and then a plus 4, and then x and then a minus 4. So we create the square, okay? And then we're going to have a height for this rectangle, which is actually looks more like a square now, of x and then a positive 4, and then going across we'll have x and a negative 4, and we're going to start by taking the x represented by the very first x in the expression, and we're going to distribute that x first. So x times x and x times negative 4. So x times x and x times negative 4. Okay, so let's do that. So we get x times x and x times negative 4. So up here I'm going to put x squared, because x times x is x to the second power. And then x times negative 4 is going to be minus 4x. Okay. Next I'm going to go ahead and distribute this 4. So it's 4 times x and 4 times negative 4, 4 times x and 4 times negative 4. So I'll put 4 times x, 4 times negative 4. Okay, so 4 times x is 4x, so I'll go ahead and add on a 4x. And then 4 times negative 4 is negative 16 minus 16. Now, in the middle, I have two like terms, a negative 4x and a positive 4x, and that's a zero pair. So the middle goes to plus or minus 0 and goes away. So we get x squared minus 16. And so the entire point of this example is, hey, if we follow this pattern, x plus 4, x minus 4, we do this multiplication, the x term in our answer turns to 0, because when we combine the like terms in the middle, they form a zero pair, and we get this, x squared minus 16. Okay? So to quickly do another example like this, x plus 10, x minus 10, okay? I'm going to do it visually. I'll distribute the x times x for x squared, x times negative 10 for minus 10x, and then I'll distribute the 10 times x for 10x, and 10 times negative 10 for negative 100, and that's x squared, and in the middle I get positive and negative 10x for 0 minus 100, so that's x squared minus 100. Okay? So in both cases, we have x plus 4, x minus 4, x plus 10, x minus 10. In both cases, our final results of multiplication have the same kind of shape to them. There's an x squared in the front, and it's subtracting a number. The middle term, the x term, disappears, and the number that we're subtracting is a special number, like 4 to the second power, 4 squared, is 16, and 10 to the second power, 10 squared, is 100. And so we're going to keep our eye on that pattern. Those are examples of something kind of cool that happens when we multiply certain kinds of binomials together. A neat pattern. Next, I'm going to show you something about notation. So here we're going to look at examples 3 and 4, and we're going to look at a special notation. Let's look at this notation. It's the notation of an exponent, okay? But we've got parentheses with this. when we put an exponent on this parenthetical expression, okay, this exponent is not attaching to the 3 or the x by themselves. Remember, when we make parentheses like this, we're making a group. That means everything in the group must be treated together, and any operation that happens to the parentheses must happen to the group as a whole. So the thing that is being raised to the second power is everything in the parentheses, not the x by itself and not the 3 by itself. So what this really means is to take the group and multiply the group times itself, which gives you x plus 3 times x plus 3. When we do x plus 3 times x plus 3, we get this perfect square, x plus 3 on one length and x plus 3 on the other length. And so, when I do my rectangle, I do x times x for x times x, or x squared, x times 3 for 3x. This square here will be 3 tall and x across, so it's 3x. And this square right here is 3 tall and 3 across, so that's 3 times 3. So adding up all of my areas, I get x times x, which is x squared, plus 3x, plus another 3x, plus 9, x squared plus 3x plus another 3x plus 9. And the middle terms are the same kind. Like terms combine to make 6x. Okay. Two important things to notice here. One, the most important, is that when this exponent is written next to this group, this parenthetical expression, the parentheses have an exponent, we are not squaring the 3, we're not squaring the x, we're squaring the entire parentheses, and that means we multiply the group times the group, okay? I'm going to do another example. X minus 7 to the second power. So immediately it's really important to remember that this means to take the group that's in the parentheses times itself. So that's the group x minus 7 times the group x minus 7. So we're not squaring the x, we're not squaring the negative 7, we're squaring the whole group. Okay? That gives us this perfect square where the height is x and negative 7 together, and the width across is x and negative 7. Okay, and I'll zoom in here. Follows the same pattern as above. The top left square is x tall and x across, so that gives me x times x. The next square is x tall and negative 7 across, so that's x times negative 7. So we've taken this x here and we've distributed it, x times x, x times x. So that's x squared. X times negative 7, x times negative 7, minus 7x. So with some color, this x gets distributed to give us x times x, and x times negative 7, x times x, and x times negative 7 to get the area of the top two boxes. Next, we'll distribute this negative 7. So we'll get negative 7 times x and negative 7 times negative 7. So looking down here, it's negative 7 tall and x across for this box right here. So that's negative 7 times x. So minus 7x. And the next box is going to be negative 7 tall and negative 7 across. So that box fills in, negative 7 times negative 7. Okay. Minus, or we could do plus here, negative 7 times negative 7. Okay, so that's negative 7 times negative 7. Now let's work with our signs and be very careful about our multiplication. X squared at the front. In the middle, we have a negative 7x and another negative 7x. That's a total of 14 negative x's, so minus 14x. And here we have negative 7 times negative 7. 7 times 7 is 49, and a negative times a negative is a positive. So in both cases, okay, whenever you get something in parentheses to the second power, that means to multiply whatever's in the parentheses times whatever is in the parentheses. And that's our first step in both cases, is to turn this exponent or power statement into a multiplication problem. And then all we have to do is multiply together two binomials, doing the distributive property and then the distributive property, or using our boxes.